Welcome, everybody. Thank you for joining us today. Today, we're hosting our RetrofitWorks webinar session about understanding domestic electrical systems. The webinar is CPD accredited, which we're really pleased about. I'm sure you are too. So at the end of the presentation, you'll be able to collect your CPD credit using the QR code that you will see on screen. I'll make some quick introductions. My name's Jason Marple. For those that don't know me, I'm the Business Development Manager for RetrofitWorks, and I'm pleased to be your host today. Presenting is my colleague, Dave Bailey. He's the Installations Manager at Your Home Better, which is a RetrofitWorks scheme based up in Manchester. This presentation was actually initially done internally amongst the retrofit coordinators within RetrofitWorks. And the feedback from those guys was that they found it really quite beneficial. So their positive feedback is the reason why we're sharing this knowledge with everybody on the call today. Also introducing Colin Boland. He's very kindly joined us from Sustain Homes. He's the operation director there. Sustain Homes are an MCS and NIC EIC accredited company, and they're currently installing solar PV and heat pumps. Colin will be involved in answering some of our Q&A questions that will come on to later in the presentations. So the reason for the webinar today is because solar PV and heat pumps, as we all know, are becoming increasingly popular in the retrofit projects. The initial house assessments are rarely performed by a qualified electrician who can check if the electrical system is ready for the installation and sound, and there's not going to be no issues. So we've certainly found that getting the right information to the installer helps the project run smoothly and avoids any costly surprises or delays later down the line. Our presenter, Dave Bailey, will be sharing his experience, so you know what to look for in your retrofit projects within your organisations. So your engagement is really important to us. And if I may, I'd like to kick things off with a very quick Q&A interactive session on Slido. We'd like everyone to take part, of course. So please can I ask everyone to have their mobile phones to hand and scan the QR code that you'll see on screen using your phone's camera. Or your QR scanning app if you perhaps use Android. All you need to do is click the note that pops up and you should be able to follow the instructions on screen. It should be pretty straightforward. So I'll just give everybody an opportunity to do the technical bit on phones, etc., and then feel free to start answering the questions, and it will give us a really good indication, I feel, as to where we're at in terms of, understanding knowledge as it stands. And don't worry, it's anonymous, so if you answer incorrectly, there's no black marks. There's a clear leader at the moment. That's very interesting. I think that's probably everyone. And the correct answer is, of course, distribution network operator. So congratulations to everybody who got that one right. If we move on to question 2 now. So which of these appliances consumes the most electricity? Is it a kettle, general lighting in the home, tumble dryer, or your computer? I think I might have actually got this one wrong if I'm being completely transparent. Okay, I think that's everybody. I'll just give a couple of seconds more just in case. Okay, the correct answer is tumble dryer. Yeah, being transparent, I might have gone for kettle there, to be honest. Okay, we'll go on to our third and final question. What percentage of domestic fires are caused by electricity? You can kind of bring home the importance of making sure these electrical circuits are correct. I think that's probably everyone. And the answer is 50%. So congratulations to everybody that has said 50%. That caught a few people out by the looks of it. Okay, well, thank you for answering those questions. That's pretty interesting. And thanks for sharing that, Sabrina, with us. So please feel free as we go through the presentations, which I'll shortly pass you over to. In the chat section, we'll be keeping an eye on any questions that might pop up. So do keep the engagement coming. We want to see some good, interesting questions in the chat, and Colin, who I previously introduced, will be answering those at the end of Dave's presentation. So we'll be keeping an eye on those, and we'll pick out a few towards the end and see if we can supply some pretty useful answers on those. I'll now move you on to our presenter for an electrifying presentation. You may see what I did there. Over to you, Dave Bailey, our installations manager. Over to you, Dave.
Thank you, Jason. So can I just get some nods of heads? Can you see my screens there? Brilliant. Okay, so hello everyone. Nice to meet you all. So I'm Dave Bailey, and I'm the installations manager at Your Home Better, which is RetrofitWorks' Manchester scheme. We deliver retrofit projects for the able and willing to pay market. And on a daily basis, my duties include obtaining and checking quotes from our network of installation partners. Hopefully, our clients will then accept at least one of those quotes and we move to an installation. Before the installation takes part, we do a meeting with everyone. We get the client, we get the installers, and I come, and we have a chat about what's going to happen in the project. So everyone's on the same page and they know like the running order of the project. And then when the installation is underway, I will make at least one quality assurance check on the project just to make sure everything's all right. Helps to do it in progress, particularly if you've got something like insulation. You need to see it before it goes on to make sure that the area has been prepared for it. If I find any problems, they get flagged to the installer who can then rectify them. And then at the end of the project, once it's finished, I'll go and do a final quality assurance check, again, making sure everything's right. I'll have a chat with the client to understand their experience and make sure they've been satisfied with everything, get some feedback, and also make sure they've got all of their documentation. Then throughout the project, I'll act as a contact point. So if anything comes up, if there are any queries, they can speak to me and I can kind of liaise with the installers and get resolutions if there are any concerns. So I haven't always done this job. About 5 years ago, I had a bit of a career change. I used to work in a bit more of a corporate setting. I used to work for like big blue chip companies on change management programs. And after doing that for a while, I fancied a bit of a career change. So 5 years ago, me and some of my friends, we set up a solar installation company. And it was there that I learned a lot of the things that I'm going to be sharing with you today. And to start off with a bit of a disclaimer, I'm not a qualified electrician. And I know this is a presentation about domestic electrical systems, but thankfully, what I'm about to share with you has been checked by several electricians. And we've got Colin on the line who will be doing a Q&A at the end, who is a qualified electrician and an experienced installer. So the reason I'm doing this presentation is because I learned a few lessons the hard way when we started out with our solar company. I would often be the first person to go and have a look at a house and do the solar survey. And then to begin with, when the electrician would turn up to do the job, he would frequently say, Dave, why didn't you tell me about this? Dave, you didn't say it was a three-phase electrical system. Or Dave, where we're going to put this massive solar battery in this house. So over time, I learned what are the important things to share with the installer up front to make our lives easier. And these are the things that I want to share with you today because it can save time and it can make your retrofit projects run smoother. So, yeah, as Jason was saying, if you think of any questions, please put them in the chat. I'll keep an eye on it, and if there's anything quick I can answer as I'm going through, I will. Otherwise, if it requires a bit more of a detailed response, we'll do it at the end and we'll do a bit of a deeper dive on there. I am quite incapable of multitasking, so apologies if I don't see something that you put up, but I will keep an eye on that. Okay, and here's an example of a nice, neat and tidy electrical system. I wish they were all like this one. So, when we go to a house, the first thing to look for is to find the main fuse. So this is where the electricity enters the property. And it looks something like this. So in the Slido, the questions at the start, we asked, what is a DNO? And you correctly answered that it's the distribution network operator. They're responsible for the infrastructure that supplies electricity to the house. This bit here, this is their responsibility, the main fuse. So as an electrician, you're not permitted to interfere with this. If it needs to be interfered with, you need to speak to the DNO to do that. If we're going to be putting in solar, a heat pump, an electric vehicle charge point, it's going to put a lot more demand on the electrical system. So in each of those cases, the DNO has to be informed of what's going to happen so they can make sure the system is ready for it. On the solar side, smaller systems, you can just tell them after you've installed it. Anything over 3.6 kilowatts, you need to do an application in advance, which they can either accept or they might say, before you can put that in, you need to make some upgrades to the system. I live in Manchester, and around here, all of well, it's all covered by Electricity Northwest. I really think they're a fantastic DNO. They're very helpful for me. I don't have too much experience with dealing with some of the other ones in other parts of the country, so I don't have an opinion on that. The main fuse is usually either rated at 60 amps, 80 amps, or 100 amps. I would say 100 amp is the more common in my experience. So the first thing to look out for once you've found that main fuse, you need to check if it is a looped supply. So if you look back about 30 years ago, a house would have a TV, a hi-fi, a kettle, and that might have been it electricity-wise. Now we've got so many appliances which increase the demand on the system. Back then, it was common, and still now in some parts of Manchester, to have a looped supply. It's most common where there's like a terraced housing, and you'll find that the supply is actually shared and it's daisy chained. So it goes into the first house, then from there comes out to the second. That was probably all right 30 years ago, but now it's a problem. Anecdotally, I heard of one street where a couple at the end, they each got a Tesla, and when they were charging them at the same time, ping, 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 everyone's lights went off in the street. So as you can imagine, they weren't very popular. So from your point of view, you want to check, is it a looped supply when you come in the house? The way you can tell, at the bottom of the fuse, you'll see two cables coming into it. These pictures are a couple that I've captured in the wild, and then Electricity Northwest helpfully showed me a nice clean example of this is what it will look like. So yeah, have a look, get a photo if you're unsure, and this will let you know if it's a looped supply. So always has two incoming cables. However, it's not always the case. Unfortunately, if you're at the end of the daisy chain, you'll just have one cable. So there's no way of knowing without contacting the DNO in advance, and that's not always possible. So just have to deal with that one. The other thing to look out for, it's quite unusual, but some domestic properties have a three-phase supply. Normally, you'll see this in commercial properties, but some particularly larger houses do have them. And it's essentially three supplies that have been combined together. And you can see in this example, there are three fuses as it comes in. And then usually you'll see like a distribution board here. And that is because the supply can be split into three like normal supplies. If you've got a big house, you might have like east wing, west wing, center, for example. So you can split it, or it is possible to have equipment that uses the full three phases. So you can get three-phase solar inverters, you can get three-phase car chargers that are really powerful. The important thing here is just to flag it and let your installer know. When you're dealing with three-phase, all of the parts need to be three-phase compatible. It will add cost to the project, so it's a very important thing to flag. Then, after the electricity has entered the home through the fuse, there will be a meter. The main thing you want to look out for, is it a smart meter? These two are examples of smart meters. Generally, if it does have an LCD display, it's more likely to be a smart meter, but that's not always the case. This one has LCD display, but it's not smart. You can see in the second picture, there are like two modules, one of them being like the communication bit that makes it smart. You might see a few of these old ones as well. If you connect solar to one of these, there's a very good chance that the dials start going backwards when you export the surplus to the grid. So a bit like the car in Ferris Bueller's Day Off, where they try and delete the mileage by reversing. But yeah, you will get found out eventually if you have a negative like that. So yeah, you don't need a smart meter, but if you've got solar PV, you will need it in order to sell or export your electricity back to the grid and get paid for it. So if you see in a house at the start of a retrofit project, they've not got one, it's worth making a call to the electricity supplier to see if they can put one in. You can always Google the make and model to see if it's smart, or there's a link here where you can put in your meter number and it will confirm if it's smart or not. Smart meters did get a bit of a bad reputation when they came in. The first generation was Smets 1, and they had a few problems. I had one myself, and they had one of the problems they had was if you change your electricity supplier, all of a sudden they stop being so smart and they go back to being a dumb meter. And that happened to me. And then when the second generation came in, Smets 2, there was a bit of delays. So yeah, bad reputation that there was some kind of problems with accuracy. I'd always recommend putting one in. If you are going to get solar, you can compare the data from that so you can see if it is accurate or not. And if you don't get one, you will be missing out on all of this money that you'd be getting for exporting your surplus. Okay, so we've come into the house, we've gone through the main fuse, we've then gone through the smart meter to record how much is being consumed or exported. The next thing that we will hopefully find is a contractor switch. So this is a main isolator, and you can use it just to turn off all the electricity in the house. And it means that you can safely work on the system. Now, if there isn't one of these, the only alternative to safely work on the system is to pull the fuse. But the electrician is not authorized to do this. It can only be the DNO or the electricity supplier. So really, we want to have this contractor switch in before we turn up to start doing the job. I'd say more often than not, certainly where I live, I'm very surprised when there is a contractor switch. But the electricity suppliers have got really good. They know what you want now when you phone up. And in my experience, they've been pretty quick to install one if you explain that you're putting in some of these retrofit measures. Yeah, you want to contact your electricity supplier to put that in. Then, after the contractor switch, we'll get a consumer unit. This is probably the most recognizable part of the electrical system. I'm sure all of you at some point have had to flick the switch up to make things work again. So what we're seeing in here, each of those switches, well, most of them are circuit breakers. And circuit breakers, they protect against overcurrent. So if an appliance starts pulling more than it can handle, bang, it will trip and knock it out. That's a great safety device. An additional safety device, you can group some of these circuit breakers together and you can protect them all with an RCD. An RCD stands for a residual current device, and that detects like current imbalance. So if anything strange is happening. Crucially, it has earth leakage protection, and this will prevent a shock by cutting off the power if it detects that the current is passing through something that it perhaps shouldn't be passing through. For example, a human being. It realizes something's wrong and immediately shuts everything down, which is a great safety mechanism. You can also have an RCBO, and that combines the circuit breaker from the normal switches with an RCD just in one unit. The advantage of that is if it trips, it only trips that one circuit and it doesn't knock the half of the house out like it would for an RCD. It's a bit more expensive for an RCBO though, so not a cost-effective way of doing it. When you install solar heat pumps, car chargers, in the instruction manual, they will specify what is required. So it's important for the installer to read that and make sure that they're putting in compliant equipment. If you're doing a survey of the house, important thing to capture here is what is the make and model of the consumer unit, because you need to buy the devices that are made by the same manufacturer and are compatible with that unit. So my advice would be to take as many photos as you can to share it. So yeah, circuit breakers and fuses. And one thing to look out for, there might be more than one consumer unit in the house. Keep an eye out for, if you can see this picture here, these blocks that I've circled, these are called Henley blocks, and they're used to split off the supply. So if you see them in the electrical cabinet, it's likely that somewhere else in the house there's another consumer unit. So make sure you find that before you've left and get a photo of it. All electrical installations have to comply with the wiring regulations. The wiring regulations, you might hear it referred to as the 18th edition. So they came out were published in 2019. Since then, solar PV batteries, heat pumps have become a lot more popular. So they're catching up a little bit to make sure all systems are safe for this kind of technology. Since they came out, there have been three amendments, and each one has addressed the emergence of these new technologies. One of them is the RCBOs and RCDs that we talked about. They have to be bi-directional, so that not only do they protect from electricity coming in, but also if electricity is going the other way. And particularly for solar, because electricity is going the other way, you really want to avoid putting solar into an existing consumer unit. The reason for that is consumer units are generally rated at 100 amps. The main fuse is also 100 amps, so that's fine. However, if you have like everything on, you're doing the kettle, you've got all the lights on, the washing machine, tumble dryer, you might be approaching, I mean, it's rare, but potentially you could be approaching 100 amps pulling from the grid. If you then start generating solar and exporting it back to the grid, that's another 16 amps of current. So potentially you could be overloading that consumer unit with 116 amps current. It's very rare and unlikely that that would happen, but it's always good practice to keep stuff like that in a separate consumer unit. A lot of solar installs that I kind of get called out to have a look at are plugged straight into the old consumer unit, so wouldn't be compliant. And even some that I've done recently, I think installers are playing catch up. So make sure that, well, you will have a competent person installing the measure, make sure that they do it all correctly. Okay. Another thing to look out for is bonding. So you can see these green and yellow earth cables. They are attached to metal pipes and it provides an earth route. If there's a problem, a fault, and for some reason these these metal pipes are electrified, the earth cable will allow that electricity to safely discharge and it won't kind of be live and create a shock. It's an important safety feature to have this. When an installer comes, if they're a qualified electrician, they will need to certify their installation. Before they can do so, they need to certify that it's safe and it needs to have this bonding. So it's not a particularly big job, but it will add some cost to the project. So it's very useful to capture this upfront so the electrician doesn't get a surprise and think, oh no, now I've got to run a cable all the way around the house from the electrical system to this pipe here. So good to just evidence that so that you can show them at the start. You need it on gas and water pipes. Sometimes water might come in through a plastic pipe. That's great. You don't need it then. Okay, and then finally, depending on what you're installing, really useful information up front is to find a suitable location where you can store, so where you can install the equipment, whether that's the heat pump, solar PV, or battery. Now, the battery, if you're installing one, does need to be very near to the inverter or the charger. In the past, a lot of solar installs were done in lofts. While this isn't particularly a problem for an inverter, batteries can no longer be installed in lofts. So there was, while we await the next amendment to the 18th edition, that's coming in 2026, there has been a PAS document, 63-100, and that is for fire safety. and it's got some recommendations as to where you can install a battery. The recommendation is outside. And to be honest, this change has been quite tricky for solar installers because there isn't always a great location. It can't go in a loft, it can't go under the stairs because potentially that could cut off an escape route if there's a fire. Wherever it is, it needs to be fireboarded so that it's safe. While this document is a recommendation, at the moment, this is the kind of the industry advice, and installers shall conform to it. If there's a backlash, it might not make it into the next amendment of the 18th edition, but until it does, everyone needs to abide by this document and install it safely in one of the approved locations. And the other part of this, it's good to scope out a few potential locations so that you can share that with your installer and let them decide. You want to have an idea how long the cable run is going to be, because yeah, that'll add cost to a job. Particularly if you've got solar on the roof and that's got to get all the way to the other part of the house. The longer the cable, the more it will be subject to a voltage drop as it's traveling the long distance. You need to have a thicker cable to get over that, and it'll need to be armored. They're not cheap. So cable run, the length of it is an important cost of a job. Okay, so to summarize, I just want to share some tips with you. So tip number one, make a checklist. So we're happy to share this presentation with you. Go through and just make sure that you've got all of these in a list. If you're a member of RetrofitWorks, I'll be happy to share my checklist with you. If you're not a member, then feel free to join up. My other tip, photos, photos, photos. Take as many photos as you can. Even knowing what I've just shared with you, even having my checklist, the number of times that I would get back to the office, look at my photos and think, oh, why didn't I take a photo of that bit? It happens all the time. So get really trigger happy. Take as many as you can. The other thing, videos are great, particularly if you want to illustrate exactly the layout of the house, how long a cable run's going to be. Just go around with a video, and that's really helpful to show the installer so they know what you mean. And then, based on what you've just learned, if there's a loop supply, straight away ask the client to speak to their DNO. The more notice you give them, the more chance it's got of getting rectified and not causing a delay to the project. If there is no contractor switch or smart meter, again, ask the client to speak to, in this case, the electricity supplier who can come out and sort that. We want everything to be ready so that when we start the install, there's nothing there that will delay us. Okay, and that pretty much sums it up. I'm sorry, I've seen questions coming up in the chat, and I got a bit distracted. I wasn't able to answer those, but hopefully Colin will be able to pick some of those up. If you are collecting your CPD credit, then please scan this code and register so that you can get it. I'll leave that on screen for a bit. And then I think, yeah, thank you for listening, and I'll hand back over to Jason for the Q&A section.
That was fantastic. Thank you so much, Dave. I found that really insightful. It's actually made me want to go and look at my own kind of consumer unit, to be honest, because as you were flicking through some of those things, pointing out the not so favourable parts, I was kind of thinking actually that looked a little bit familiar. So it's kind of encouraged me to go and have a look at my own electrical system and yeah, perhaps draw my own conclusions on that. Really great presentation. Thanks again, Dave. I'm just wondering, Dave, as you were going through there, in terms of the homeowner, Do you find that the homeowner or the person renting the property, do you kind of find they have a generally good understanding of this kind of stuff, or when you're in conversations with them, are they confused? They don't have any kind of understanding? Because I think some of that information would be really useful for homeowners, generally speaking. So, what's your experience of that? Do you kind of find they have an understanding or none?
Full range. Some
Mm.
people don't have a clue, some people know more than me. So I think your language is important. So rather than throwing terminology at them, say things like, you know, the thing that you have to flick up when all the lights go off. Oh, yeah, I know that. It's under the stairs.
Yeah, yeah, makes sense. And how often do you kind of find something that, is either kind of wrong or quite seriously wrong? Do you kind of come across, does it vary, or is there quite a lot of shocking stuff out there that you see during your day to day?
Yes, there's quite a lot of shocking stuff that I see. I would say more often than not, there is something that's not ideal. It's very rare that you go to one that's perfect, ready to install. That may be a regional thing. I operate mainly in Greater Manchester. I'm not sure if Colin has a different take on this.
Yeah, no, I can second that. We're based in Watford, so our DNO is UK Power Networks and SSEN in this area. You come across quite a lot of shocking things that don't comply with the latest regulations. So, yeah, I can definitely confirm that. So,
Cool.
Yes,
Just before we continue, I've just seen some messages coming in about this QR code and the webinar not activated. We'll just have a look at that behind the scenes and get that set up. And we will send you this code so that you can do it after the event, but we'll see if we can get it sorted now. Thank you.
right, thanks, Dave. We'll put the QR code back towards the end. Okay. Colin, there's a few bits and pieces coming up in the chat here during Dave's presentation. I wondered if I might hand over to you and see if you could talk on some of these bits and pieces that we're seeing in the chat.
yeah, of course. So, yeah, thank you, Jason. So, Dave, thank you again for the presentation. That's excellent. So, just going back to the first two questions we put out to the group. Um, Jason, you said yourself that you got that one incorrect. Uh, Common misconception, really, because I think most people who've got a smart meter and they've got the visual part, you turn the kettle on and you see it go red, and everyone panics. In reality, the kettle's 3 kilowatts, roughly the same as a tumble dryer, but the tumble dryer is going to be going for a lot longer, at least half an hour. So we measure everything in kilowatts. So if you're using 3 kilowatts for a kettle, you're doing it for a couple of minutes at most. If you've got a tumble dryer on for an hour, you're using 3 kilowatts, 3 kilowatt hours. So you're paying a lot more for that. So yeah, so you're not alone in getting that one wrong. All right. And the other question, DNO, obviously you've touched on this, Dave. Distribution network operator. There's 14 in the UK at the moment. As I said, mine is UK Power Networks. Currently, we're doing a lot of solar and heat pump installs around London, Hertfordshire, Bedfordshire, Buckinghamshire. So we fall across UK Power Networks and SSEN. And you can see differences just between those two companies. I won't say which one we prefer, but certainly you touched on it when you make an application for a solar install. If it's above 3.67, you have to do a G99 application. Some of those providers can get that back to you within about 2 or 3 days. Some take up to about 4 weeks. So it can be a delay for a process for any sort of G99 application. All right. I'm just going to go through the questions. There's not loads, but I have got some internal ones as well. So if I just go open the chat. Uh, right. So John, to export, do you also need to export MPAN? Right. So Dave, you touched on this already. You do not necessarily have to have a smart meter to have solar. You can benefit from generating and consuming the energy. To benefit from selling it back to the grid and being open to the best rates, you need a smart meter, but you also need something called an MCS certificate. So my company, Sustain, we're a MCS accredited installer, NIC accredited as well. If you had solar installed by someone who wasn't MCS accredited, you would not be eligible for those export rates. All right.
Yeah,
Uh,
just on that one, John, you mentioned the export MPAN. So that's like a kind of separate meter number, isn't it? That shows it going the other way. If you get in touch with your electrical supplier and say you want to go on an export tariff, they'll probably ask for your MCS certificate. Once you've sent them that, they'll set up that export MPAN for you and you can export. Thanks, Colin.
no worries, no worries. Right, so just having a look through the chat. So, are there air source heat pumps that are compatible with a three-phase supply? Yes, certainly there are. So, a single phase or a three-phase air source heat pump will be sized accordingly to the demand of the property. So as you get bigger, you're more likely to go into the three-phase realms. To have a three-phase heat pump or three-phase inverter or three-phase car charger, you do need an existing three-phase meter and distribution board. So slightly different to a single-phase consumer unit. It's not uncommon for a property to have a three-phase meter, but they don't have a three-phase distribution board. Dave, you touched on it earlier. They might only use one of the phases for the main house for a consumer unit. They might use phase two to spur off to maybe a garage or a barn conversion or somewhere else, or an office building in the garden. So for assessors, it's quite clear. Sorry, it's not always clear. Sorry. For assessors, it's quite common to misunderstand that they've got three phase. They can see the three phase coming in from the DNO. They can see the tails. They can see the meter, but they cannot see the three phase distribution board because it's just a single phase consumer unit. We've come unstuck over the years on that where our surveyors haven't picked that up. So we've maybe sold a three-phase inverter, but there is no three-phase distribution. So just something to be mindful of. If you do have three-phase coming in, brilliant. It's a good start. You could always upgrade the distribution board to a three-phase by a qualified electrical installer. If you want a three-phase heat pump or EV or PV, and you don't, you'll have to apply for the DNO, but it can be expensive. Reason being, there's civil engineering involved, and it can get very, very expensive. So just bear that in mind as well. Move on to the next one. Right, question from Ian. So, is not having a separate consumer unit for a solar non-conformity or preference? Bear with me, sorry. So it can be both. In reality, 99% of the solar installs we do, we install a new standalone consumer unit. Reason being because they have to have, first and foremost, they have to have a SPD device, which is a surge protection device. They also need to be on an RCBO, and it needs to be bi-directional. So unless you go into a property where they've had a brand new fuse board, maybe in the last 12 months, there's a spare way on that board that you can add an additional RCBO to, and it can be bi-directional. You can add to that board, but that is really uncommon. So most of the time, you go into a property, and they've got a fuse board. Not necessarily unsafe, but it just doesn't comply for the new regulations for installing a new circuit for a PV. So yeah, 99% of the time we put in a new standalone consumer unit.
If I can just add on to that one, we spoke about this earlier because it's quite a contentious issue. Really, the wiring regs are catching up with all of this kind of new technology that's coming in. So whoever you speak to, you might find a few differences of opinions, and it's kind of an ongoing debate. But there's definitely good ways to do it and bad ways to do it. I agree. I think putting in a separate consumer unit is definitely the right way to do it. Whether that's enough is another conversation, but yeah, I'm sure we'll find out more.
Well, as us as installers, Dave, we factor that in within the installation cost, because it gives you spare capacity as well. Because if someone has a heat pump or a solar, the likelihood is if they don't have an EV charger, they are going to get an electric vehicle at some point. So you're leaving spare ways within that new board. The other option, of course, is that the consumer can change the whole existing board. So if you've got let's say a board that's over 10, 20 years old, we can change that full consumer unit for an RCBO, 18th edition, SPD protected fuse board, so we can add our circuits there and leave spare ways for future proof.
Right.
Right, so sorry, just there. So Sam, are fire rated clips now required for our SPV installation or just over exits and doors? So again, this was another rule brought in into the 18th edition. So you're correct. So if we clip any cables internally above exits or doors, fire escapes, we use fire clips. When we used to do full house rewires and new installs, we would use fire clips throughout. The cost difference is minimal, and to tell someone to use fire clips in one area and standard clips in another, it just doesn't work. So we install it in every sort of installation we do. Any thoughts on that, Dave?
No, agree.
Perfect. Right, so neutral sharing cable. Can this cause any issues with an installation? So Mohammed, are we talking? I believe we're talking about an earthing system, so a TNCS, also known as a PME. So it's protective multiple earths. So as you're incoming to the property, the neutral and the earth share the same path. Then it splits. So then it gets to the head, gets to the main fuse. From that point, it then splits. It's something that assessors or surveyors should be mindful of, because you're trying to clarify what earthing system is in a house. It's on one of your first slides, isn't it, Dave? Different types. Can be quite easy to spot. So TNCS, where I say the earth, if you think of the sea, it's combined. So the earth and the neutral share the same fault path back to the grid. So if it's coming up through the ground from below your meter, from the head, it goes down. Once you get to the meter, you'll see. Sorry, once you get to the head, you'll see a neutral connect. You'll see a neutral connection, sometimes labelled, not very often, but you'll see an earth connection coming out of that. Then that will go to something called an MET, which is a main earth terminal. From that main earth terminal, it goes to your fuse board. So that will be a 16 mil earth. Then also you mentioned bonding in Dave's slides. If you are required to bond, which in most cases you are, the gas and the water, then you'll see another 10 mil earth go from that main earth terminal. The flip side of that, another common system is a TNS. So quite easy to spot with this one. So you'll have the clamp around the external casing of the incoming cable from the DNO. They use the external casing as the earth path. So there'll be like a strap, a clamp around that, and then an earth going from there. You'll see a fly lead go from there, and that will go to the main earth terminal. From that main earth terminal, again, it goes to the main fuse board, and then it goes to the gas and the water if required.
And does that influence the job in any way, which technology it uses? Do you always want to know that up front?
Yeah, on our surveys, for solar, so first and foremost, if anyone's got a new fuse board, it should be done. So when an electrician changes a fuse board in the last sort of couple of years, the onus is on them to make sure it's bonded. So it's uncommon to go to a property when there's a newish fuse board. The gas and the water should be done. On our surveys, we have photo prompts throughout our surveys. So as you mentioned, Dave, you can't get enough photos on these assessments. It's one of the questions. It's a photo prompt. Is the gas bonded? Yes or no? Take a photo. If it isn't bonded, we'll do that. We'll put that in as part of the install.
Cool. I think that's a good thing to add into the presentation for next time, actually. I don't think I covered that in too much detail.
No, okay. Right, so I've got some internal
There was another
questions.
question as well. Can you explain what an inverter does?
Yes, so an inverter. So it converts AC and DC currents. So you'll have an inverter, a PV inverter. So if you've got a solar install, if you start from the top and you've got solar panels on the roof, you'll generate electricity from the sun and the irradiance. That is DC because the panels are wired in series. So it means it's DC, so it's direct current, so the energy flows in one way. That flows to the inverter. We do not use DC in domestic households. It can be used in batteries and industrial sites. So what the inverter does is it's effectively the brains of the system. It converts the DC input and then it converts it to AC, so we can benefit from the generation of the sun to consume that energy. And then by default, if you've got solar on the roof and it's a sunny day, you're generating DC power that's going into the inverter. You're then converting that to AC for you to use. If you have met your requirements, you've got the washing machine or you flip the kettle on, and you've still got excess energy, it will then go to the battery. Later that night, this is a solar battery installation. Later that night, when the sun's gone and you've got 90% of battery power there, it will work exactly the same way. You turn the washing machine on, you've got battery power there. The DC power from the battery will go via the inverter, and then it will change it to AC power, which is alternating current, which is a lot safer. It's the only current we use in the households, and then you can benefit from that. Anything to add with that one, Dave?
It just made me think that something that I've seen a lot more of recently, as you said, AC electricity is safer. If you've got a lot of solar on your roof, potentially that's a lot of DC electricity. If there is a house fire, it can be quite dangerous for the fire service to have live DC up there. So a change that I've seen coming in, optimizers are becoming more popular,
Yep.
particularly on commercial installs, but also on domestic. Um, if we do another one of these webinars on solar, perhaps we'll go into a bit more detail on that. They also contain a safety mechanism which will turn off, disconnect each panel. So the shock would only be as powerful as a single panel rather than the whole array together.
Yep.
There are also some other products like foam that you can spray on it so that the sun can't go and generate a live current. But I think that's something that will become increasingly prevalent in the next couple of years.
Yeah, you're quite right. So you touched on that on plant location, didn't you? So you can't put inverters or you can, but you can't put batteries in lofts anymore. So we don't do that. So as you said, Amendment 4 is coming out in 2026. It's a draft format at the moment, but you certainly can't do that. But what we do as well, so when on our surveys, we are mindful that we don't run DC through the houses. So that's external, because quite rightly, as you said, when you're generating sun, there's no fuse protection on that DC power. There's no RCBOs. It won't flick under fault conditions. So there is an element of danger there. So you eliminate the risk by running that externally, not within the house.
Really interesting. Thanks, chaps. That technical discussion in an open forum such as this is so useful. Really interesting stuff there. I actually kind of think we could have probably run this for another 2 hours, to be honest. I don't think we've quite got through all the questions, and it's amazing the kind of debate that it starts, and it seems a bit of a moving target at times with new legislation coming in as technology advances so quickly. So really good there, Cullum. Thank you so much for joining us, Cullum. We really appreciate it.
No, thank you for having me. Thank you.
I know you guys are extremely busy. I've put the link for Sustain's website in the chat there. So if anybody wants to find out some more, get in touch with Column, or they're doing some really amazing work as part of the membership with RetrofitWorks. So yeah, thank you so much for joining us, Colin. That was really, really fantastic. And thanks again, Dave, for the presentation and input there.
No problem. Thank you for having me.
Pleasure. So apologies again for the CPD scan that didn't work. If one of my colleagues could put that back up, it actually seems to be it's a timing thing. So that will actually be live again now. I know we shared the link in the chat there, but just for a convenience sake, if someone would like to share that, I'm sure some people will be using it as they exit the meeting today. So that kind of draws us to a close now. Super interesting stuff, as I said. Thanks again for everybody's involvement. Also, special thanks to my colleague Sabrina for putting this webinar together today. As everybody can imagine, it takes a surprisingly large amount of work to put these together. So special thanks to Sabrina for doing that.
Thanks, Justin.
I'd also like to remind everybody that there will be a survey circulated tomorrow We're looking for feedback on what you thought of this webinar, especially if you would like us to cover a specific topic or subject. We're very much open to that. So if you've got any feedback, please keep an eye out for the survey tomorrow and fill it in and send it back to us. Also, if you would like more information on our membership packages and how they may suit you as individuals or your organisations, please get in touch with the membership at retrofitworks.co.uk. We look forward to hearing from you there, and hopefully this has sparked some interest. Well, thanks again to everybody involved. Thank you to you guys, everybody that joined us today. We're going to be doing a series of these webinars, all with CPD attached to them. So, they do hold a great deal of value. So keep an eye out on our socials, LinkedIn especially, for more of these webinars. And hopefully we'll get some great feedback from you on what direction you want us to take us in. Any topics you want covered, let us know. But thanks again, everyone. That draws us to a close. Enjoy the rest of the week and into the weekend. Thank you.
Excellent. Thanks ever so much.